I'm Yeatman. I'm Professor of Microengineering at Imperial College. I'm also the co-director of the college's Digital Economy Laboratory. I'm leading a project called Digital City Exchange, which is a big collaboration involving 4 engineering departments and the business school at Imperial. I'm curious about how microtechnologies can add intelligence to systems of all kinds, systems in our personal environment, in our commercial environments, and in the natural environment. In our cities we have a number of complex systems. This includes electricity supply, transport networks, the weather, other utilities like gas and water, and of course commerce. And each of those systems has a lot of sophistication, it has a lot of sensing and a lot of data, but at the moment they don't work together so much. So we're looking to find ways to make links between the systems so they can share data to enable new applications and new efficiencies. One of the challenges in urban systems is that the infrastructure cost and scale tends to be dominated by the peaks in their loads rather than the average load. A classic example of peaks is an ad break in a popular television program. Everyone turns their kettles on and there's a massive electricity demand. Peaks also occur in other systems like communications networks, when people all get on their phones at an event, for example, or everybody wants to download something because they've heard some breaking news item. Then of course the traffic network and public transport network are full of peaks. There are 2 basic solutions to dealing with peaks. One is to pull resources together to meet the peaks, and the other is to suppress the peaks and push the demand into quiet areas. If we really want to do sensing on a massive scale, where we measure everything about all our environments all the time, then we have to do it wirelessly and we have to overcome the powering barrier. I'm working on an approach to this problem which involves making microscale power sources that draw energy from their ambient environment, from motion, from airflow, from temperature differences and temperature changes with time. This means we can make power supplies that are perpetual and therefore eliminate the battery problem. In 5 years' time, we can imagine a building management system could take predictions from the weather reporting and know when heat and sunlight is going to arrive, and from that better control its internal management. Looking further out, say 10 years, we can imagine more sophisticated systems, a building management system which is personally responsive, where lighting and air conditioning follows individual users and only provides those services exactly where and when they're needed. Of course, looking further out, say 20 years' time, as systems become ever more interconnected, then the boundaries between systems and the boundary between industries will start to blur ever more. So what we think of now as a transport company, a car company, energy company, that will be completely altered in 20 years' time. What we're talking about is ever smarter individual systems joining together to make a highly intelligent, interconnected urban environment with huge benefits for the industries, the public services, and of course the individual users, the citizens of a city.